Hello ladies and gentlemen, in this video, I'll show you how to make a Lumos wand using components from various discarded devices. You can call them scraps, if you prefer. If you don't like handling scraps or don't have any, you're welcome to purchase all the components, which I'll recycle to give them a second life in my project. On my desk, you can see the main components: a wooden stick I found in the park a few days ago, a flashlight that no longer works and isn't worth repairing, and an old vape that a friend of mine gave me after using it. The disposable vape isn't rechargeable, but the lithium-ion battery inside typically lasts 500 to 1000 charge cycles. Since the LED we'll be mounting on the wand doesn't require much power, this means the witch or wizard who uses it will graduate before the battery runs out. To charge the battery, you'll need a TP4056 charging board like this one. It's the only thing you'll need for this project, but trust me, it's very inexpensive. The next step is to disassemble the vape. To do this, you must wear protective gloves, as the liquid inside the product should not be touched with bare hands. Vapes come in different sizes. You can see a few here. I chose this one because the battery is thinner and is the only one that fits inside the wooden stick. To give these components a second life, you'll need a soldering iron to make the electrical connections between the various components, a drill to cut the board on which the leads are assembled and to carve the various recesses inside the wooden stick. Don't worry if you don't have a drill. I'll show you how to achieve the same result using a hacksaw, sandpaper, a utility knife, and elbow grease. These are the components inside the vaporizer. I simply removed both ends and pushed them out with a pencil. Don't use metal objects to do this. You can see the pressure sensor, also called a capacitive sensor, the lithium battery, be careful how you handle it, and the container with the liquid. Don't touch it with your bare hands. If you accidentally touch it, wash your hands as soon as possible. These are the components inside the flashlight. The battery no longer charges, and it's impossible to identify its specifications. The wires came loose easily as soon as I touched the board. Believe me, trying to repair it will cost more than buying a new one, but some components inside are still usable. In this project, I'll focus on the leads. There are many different leads. 3mm and 5mm are the most common, but they aren't suitable for our project. They're used as indicator lights and aren't bright enough. Then there are these SMDs, used in many devices like light bulbs, flat-screen TVs, and monitors. Finally, we have the flashlight ones. I decided to use one of these because they're bright enough to illuminate what's in front of them, but without blinding anyone if you shine the flashlight on them. To cut the board, I'll use this power tool. All you have to do is trace the lines on the board and choose the right accessory. I prefer to keep a portion of the board instead of desoldering the LED, so I can later insert it into the recess I'll create in the wooden stick. This process will create a lot of dust and flying particles, so be sure to wear a dust mask and safety glasses. This cutting disc breaks very easily, and you don't want a piece flying into your eyes. If you don't have one, you'll have to use what you have, whenever possible. Avoid sharp tools like a utility knife and use a hacksaw and wire cutters to avoid injury. Then proceed using human strength and elbow grease. Before cutting the board, be sure to identify the polarity of the LED, as it will only work if properly powered. You can read the minus sign on the board, which means all leads connected to the outer trace must be connected to the negative terminal of the battery. I placed a red dot near the inner trace so it's easy to identify after cutting. I successfully cut the LED from the board using the power tool and cutting disc I suggested earlier. I also tried other options, like these wire cutters and a hacksaw. It will take longer, but it's doable. Now I'll solder 2 terminals and show you how. I'll use this 2-position selector to create 2 different levels of illumination for the wand. For the same reason, I'll also use one of these diodes, the black ones with the white stripe. But this time I'll take them from the board using the soldering iron. Depending on the result I get, I'll decide whether it's necessary to use other components. For users who prefer a wand with only the on-off function, I will also show a basic circuit. On the desk you'll see the basic circuit diagram showing how to connect the various components. On the charging board, there are solder points for connecting the battery and the load. This means the load will not be directly connected to the battery, which will protect the battery from short circuits and overdischarge. You'll already be familiar with lithium batteries, since we took them from the vape. Be very careful when handling these batteries, as they tend to catch fire or explode if handled improperly. Be careful to observe polarity and try to be as quick as possible during the soldering process to avoid overheating them. Here's the board that houses the LED. Be sure to observe polarity, as LEDs only work when connected correctly. Finally, we have the switch. Be sure to use a push-button switch that only closes the circuit when pressed. Also, make sure the button protrudes enough to pass through the wooden wall we'll create in the stick. For a more advanced model, simply replace the button with the 2-position selector. The 2-position selector can open the circuit and prevent current from flowing. In this position, the LED will remain off. It can also open the circuit in 2 different positions, allowing you to power 2 different loads depending on the selection. In the flashlight, the 2-position selector was used to power half of the LEDs in the first position and all in the second. I, on the other hand, will use it to power the LED via the diode in the first position and directly in the second. A diode's forward voltage is the typical voltage drop needed for current to flow through it in the forward direction, acting like a one-way valve that needs a certain push to open. The value usually goes from 0.3 to 0.7 volts. In our case you can read the value of 0.576 volts. By powering the LED through the diode, the voltage will be 0.576 volts lower than the maximum. This will cause the LED to produce a lower light level. To speed up the soldering process and avoid stressing the various components with heat, it's good practice to tin all the terminals. Apply a little flux to the surfaces, making sure the soldering iron is hot before melting a little solder. After that, it will be much easier to connect all the components. As you can see, I've completed all the remaining connections. I should point out that I won't be using this circuit for our project. I use this type of wire because it holds its shape and will help you visualize the schematic. Now let's connect the charging board to the power supply. The red LED indicates that the battery is charging. Once that's done, we'll test the circuit to see if it works. The blue LED on the charging board indicates that the battery is fully charged. Let's start the test. Be happy, it works. As you can see, the LED stays on until you release the switch. I replace the button with a selector. In the off position, the LED will remain off. Selecting the first position will have a medium brightness level. Selecting the second position will have the maximum brightness level. Now you have Lumos and Lumos Maxima. Enjoy! Let's cut the stick in half. I replaced the old one with a thicker one, which has enough space to accommodate the charging board, so I won't need to add a handle. It also has a nice flat surface. Ideal for the selector. I'll try different procedures and let you know which one works best. It wasn't easy at all. I'm not used to working with this type of material, so it took me a lot of time and effort. I used this circular saw, and you can see how hard it was. Maybe because the wood is green, I don't know. I created 2 slots on either side of the stick and then, using them as a guide, I split the stick in half with a very sharp utility knife. Don't forget to wear protective gloves. As a finishing touch, I flattened the surface with sandpaper. To carve the various cavities in the wooden stick, you'll need a power tool. All you have to do is trace the layout into the stick and choose the right accessory. As before, this process will create a lot of dust and flying particles, so be sure to wear a dust mask and safety glasses. If you don't have a power tool, you'll have to use what you have, whenever possible. Avoid sharp tools like a utility knife and use sandpaper and rasps to avoid injury. Wrap the tool around something the same size as the cavities you need to create in the stick. After creating all the slots inside the stick and making sure everything is in place, I'll proceed with the connections. Now that the various component positions are ready, all that's left to do is position and connect them. To do this, you'll need a soldering iron to make the electrical connections between the various components. This time, since the circuit is designed to last, we need to make sure everything is properly installed. We'll protect the battery and all the cable terminals from possible contact using Kapton tape and heat shrink tubing. Don't skip this step because we want to prevent anyone from getting hurt due to our negligence. On the desk you can see all the installed components. The LED, battery, diode, switch, and charging board have been connected according to the diagram. I added some paper tape just to hold everything in place. I'll remove it before gluing the 2 halves of the stick together. Let's try it one last time. After gluing, I added some wire to keep everything tight. Unfortunately, I wasn't able to fit the 2 halves together perfectly because there's still a small gap. I'll add some glue and some sawdust. I can't think of a better option. I'm not an expert on this subject, so feel free to comment if you have any good advice. I won't show the final result because I'm impatient to add this video and I don't want to wait for the glue to harden. You've already seen that the wand works. So let's leave a little imagination for last. See you on the next project.